For this video, we're going to have a reminder about our vocabulary. So we have our radical expression. Remember, the radical expression talks about this entire thing that's got that radical symbol in it. Then we have the radical, which is just this square root symbol here. The radicand is the number that's inside the radical. And then we have the index. The index is the little number that goes on top here that's telling us what the root of our value is, the root that we are taking to get our answer. Thank you, Brooke and Sophia, for that reminder. Then, because we can have indexes that don't have to just be 2, we have things such as cubed root and fourth root and fifth root, etc., instead of just square roots. So if we have the cubed root of 8, that's going to give us a value of 2. I know that because 2 times 2 times 2 equals 8. I'm taking the answer, I'm taking the value, and I'm multiplying it 3 times because it has a root of 3. Then, therefore, we can also have the cubed root of 27 equals 3, and we know that because 3 times 3 times 3 equals 27. It's very similar with a fourth root, but now we're looking for a number that we multiply by itself 4 times to get our radicand. So the fourth root of 16 is 2, because 2 times 2 times 2 times 2 is 16. I multiplied that 2 4 times. And then the fourth root of 81 is 3, and I know that because 3 times 3 times 3 times 3, that's going to give me 81. So that gives us something to think about. So think about square root 25. We know that that's going to equal some number that's multiplied by itself 2 times. It's going to equal our radicand of 25. So we know that we can take the number 25 and break it apart into 5 times 5. So I keep that inside my radical. I know that if I have 2 numbers being multiplied by themselves, I can write that 5 times 5 as 5 squared. I know that I can then take this square root of 5 squared, and that's going to give me the number 5. My square root symbol and my square cancel out, and I get 5. However, something to think about, is 5 the only number that you can square to get 25? What this begs is, what about this? Square root of 25 can also be broken up into the square root of negative 5 times negative 5. Because think about that. What happens when you take a negative times a negative? It's going to give you a positive. So negative 5 times negative 5 also equals 25. So that means that negative 5 squared is going to equal 25. So the square root of this negative 5 squared is going to equal negative 5. This means that sometimes we are going to have numbers that have more than one root. And we need to figure out, okay, when are we going to have numbers that have more than one root? So we want to think about this. When we have a negative radicand, so when this number that goes inside our radical is negative, let's look at these patterns. So when we have a negative 2, if that's getting squared, it means negative 2 times negative 2. 2 times 2 is 4. A negative times a negative is a positive. But now if I have negative 2 and that's cubed, I have that negative 2 times negative 2, that gave me 4, but now I'm multiplying by another negative 2, so that means this positive 4 and this negative 2 give me a negative, and 4 times 2 gives me 8. If I now take negative 2 and I raise it to the 4th power, I have positive 16. If I have negative 2 and I raise that to the 5th power, I have negative 32. So we should be noticing a pattern here. What we want to discover is that if we have an even index, Remember that index is what root we're taking. In this case, it's what is this exponent that we have here. If our exponent is even, so if it's a 2, or if it's a 4, or if we kept going 6, 8, 10, 12, and so on, what that's going to do is it's going to give us a positive radicand. This value here is positive, and because that is positive, we're going to have two real roots. We're going to have the root of a positive value and the root of this negative value, and we can see why right here. But when our index is odd, that means we're going to have this negative radicand. So this right here, this -8, or this one right here, this -32, that happened when we had a cube, when we had a fifth. It would happen if we had a seventh root, and so on. When we have that odd index, we're going to have a negative radicand, and it's only going to have one root. Remember, this is only the case when our radicand is negative. All right, so here's just another way to look at it. If we're taking the nth root of b, when this radicand is negative, we're going to have one root, and it's going to be a real root only when the index is odd. So in other words, we can only get a value, a real number value, when the index is odd, if this number inside our radical symbol is negative. If our b is 0, if this number inside our radical symbol is 0, we're going to only have one root. It's going to be 0. And remember, -0 does not exist, so we can't have a -0 inside our radical. And then lastly, if b is positive, if the number inside here is positive, it's only going to have one root if our index is odd. It's going to have two roots if our index is even, the negative and the positive.